Good morning, good morning, friends. I hope you are all doing very, very well today. It is Friday. Happy Friday. So let's go over the expectations for today. Remember, you need to do the attendance check-in before 3 p.m. You need to watch this video, and then you need to complete the practice as well as the quick quiz. So let's get started, shall we? All right. So we are talking about graphing logarithmic functions. And as a reminder, let's see if I've got Desmos open. I do not. Let's open Desmos real quick. If we're talking about inverse functions, the relationship between two different functions, we can think about it in terms of how we end up finding these things. And you're like, what, Miss Wood? Okay. So typically, if I were to say to you, find the inverse function of any function on the world. So if I were to give you y equals 1/2 of x minus 4. To find the inverse function of this, all you have to do is swap the x and the y. So you would simply, and then you'd have to solve it so you can graph it, but what's nice using this graphing calculator, we don't have to do that. All we have to do is swap the x and the y values. So x equals 1/2 of y minus 4. Now, what ends up really happening, besides us flip-flopping those or swapping the x and the y values, what we're doing is we're technically reflecting this, and I can make this a dotted line by clicking and holding on this, and then I can change that to a dotted line or change the color if I would like. What I'm technically doing is reflecting this line across this line. That's what an inverse function does. So I'm going to keep that line there. And I'm going to do a log function. So if I say that y equals, I'm going to do an exponential function. So y equals 4 to the x. Because the inverse of an exponential function is a logarithmic function, the first thing I could do is just flip-flop the x and the y, which I showed you before. 4 to the y. Oh, wait, look. They flip-flop. They fold along this y equals x. But mathematically, I can't find this. I need to know what the inverse operation is. And that's where logs come in. That's what a logarithmic function is. It's simply the opposite of an exponential function. So in order to graph this, if you want to use the graphing calculator, great. So it becomes y equals, you click on this function button, and you can see there's no logs here. Those are all trig functions. Stats, yep, nope, not there. Distributions, that's what DIST stands for. Nope, let's go to miscellaneous. Now here log is log base 10, and ln, that one is our natural log. We're actually going to use this one, which is the log of a. And then you put the base, which is 4, and then you put the x. Now, if you notice, that black line and the red line are the exact same line. And that's because this is the exact same thing as this. Nifty, huh? Which also proves to us that the inverse of an exponential function is a log function. Okay, now you could use Desmos graphing calculator and use this to find a million things. Oh, let's talk about the parts of this. I'm sorry. Asymptotes. An asymptote is a line that approaches it closer and closer and closer and never touches it. So here, this is going to, the purple line, it is going to go off into infinity up and always to the right. It's just going to keep going. But to the left, it is going to get closer and closer and closer and closer and closer to zero. It's never going to touch zero. That is its asymptote. So it has an asymptote of x equals 0. So that is for the exponential function. For the logarithmic function, because we flip this across the line y equals x, it's actually, the asymptote is here. It is, instead of being approaching x equals 0, or sorry, y equals 0, we're now looking at x equals 0. So an asymptote is that straight line that it approaches. The domain and the range. So remember, domain is all of the x values. The range is all of the y values. So as you can see here, let's just look at our log function. This for all of the x values, we can see that for every x value, it is positive. It will never get over on this side. And so it's going to be, the domain is x is positive. X is greater than 0. The range is all y values. And we can see that it is going to go on forever and ever and ever and ever and ever in the negative direction. So it's going to include all negative y directions. And it doesn't happen as quickly, but eventually, if I were to zoom out forever and ever, it could eventually get away from that line. It doesn't appear to be right now, but it is all positive, or all y values. So all real numbers for the range, and it is approaching x equals 0 for the domain. Okay, so asymptote, range, domain. Let's look at the notes page. Okay, if I were to give you this particular equation, what's nice about this format is it gives you specific information. In fact, it gives you the information. This is the h, and remember, it's a negative h, so that tells you where the asymptote is. So in that last example that I was just showing you, when we had the log base 4 of x, because it was minus 0, we can see very quickly that our h is going to be equal to 0. We could also put a plus 0 afterwards, which is going to be our k. But our k isn't going to tell us anything, according to the notes on this one. The domain is always x is greater than h, so x is greater than 0, and we'd already looked at that. The range is always going to be all real numbers, okay, which we looked at the graph and determined that. Then it says if b, so if the base is greater than 1, so is this greater than 1? Yeah, it is. So this is going to move it up and to the right. If b is between 0 and 1, which means it is going to be a fraction or a decimal, I cannot wait to get the new charger. Okay. Then it is going to, the graph is going to move down and to the right. So it's going to move like this. Makes sense? Okay. So let's look at a couple of these and see if we can figure these out. Now, when in doubt, use Desmos. Try and figure it out yourself, and then use a tool that you have available to you. Very simply, go to the Desmos graphing calculator, graph it, and look at it. Okay, so here is my base. Oh wait, there's no number there. Remember, this is 10, base 10. We work in a base 10 system. So the b is going to be equal to 10. So if b is greater than 1, it's going to go up and to the right. Alrighty. Then we look at, remember, this is the opposite of this. What's the opposite of positive 3? It is negative 3. So our h is actually negative 3. Now that is our asymptote. So x is at negative 3. That is where our line is going to approach. And I can sketch this very quickly by understanding that it is going to get as close to this as possible, and it's going to go up and to the right. So it's going to get super, super close up and to the right. Now it's not going to be perfect. It's sketch. So what is the asymptote? The asymptote is located at x is equal to negative 3. The domain, so all of our x values in this, is going to be everything that is greater than negative 3. And our range is all real numbers. Okay, let's look at another one. Okay. So again, is this inside parentheses? Let's first talk about the x's minus 1. Is this inside parentheses? No, it is not. So we need to keep in mind that because it's not in parentheses, this is talking not about our k value, sorry, our h value, but this is our k value. So if we're looking at this particular format, our b, our base is 1/3. Our h is 0. And our k is negative 1. So our asymptote is located at 0 because we do not worry about this k value. We only worry about our h. Where x is 0, our domain is anything greater than our h, and our range is all real numbers. Now, what does the graph look like? Remember, it said if it's between 0 and 1, it goes down and to the right. It's approaching 0, so sorry, the asymptote is located at, yeah, x equals 0. So here's our asymptote. It's going to approach this, and it's going to go down and to the right. Everything is greater than 0. All of our range is all real numbers. And let's check using Desmos Graphing Calculator to see if we're right. So we can get rid of this one, and it's the log of, where's our fraction? Oops. Start over that one again. Okay, so y equals functions, go to our log button, 1/3. It appears as though I have to use little parentheses. You know, we all have technical difficulties, and there's a reason why I show practicing this. I'm going to put this in parentheses. Nope. Control C. Okay, so it appears as though, well, I know that I should be able to graph this. Don't you love it when you're frustrated and you can't get it to do what you want it to? There we go. It's weird looking. So it was -1. And if we do, oh, let's do a decimal approximation. Try that. We can always do a workaround. Okay. So we can see it does do that exactly. It approaches the 0, It is all real numbers, and we are good to go. So, when in doubt, use a decimal in the denominator. Okay. So, again, let's look at this one. So the base is 5. That tells me it's going to go up and to the right, because the base is right here. The h is opposite of, which means it is -2. And the k doesn't matter, but the k is equal to 1. It tells us that it shifts, but that's okay. All right. That means our asymptote is located at x is equal to -2. So we can draw our vertical line. That was really bad. Here. It's going to go up and to the right. Again, bad sketch. That means our domain is everything greater than -2. And our range is all real numbers. Natural log, same thing. That means our base is e, which has a value that is greater than 1. That means it's going to be up and to the right. Our h, remember it's the opposite of, so our h is equal to 4, and we don't care about the k, although the k is 2. The asymptote is where h is equal to 4, x is equal to 4. Again, very bad line, sorry. Hand went off of the... Oh, wait, I have a line tool. Okay. It's kind of fat. Anyway. Then we do up and to the right. That means our domain is everything greater than 4. And our range is all real numbers. Okay, those are your notes for today. Use this or the Desmos graphing calculator to help you on the practice as well